Okay, this problem is going to ask us to to perform some analysis using our linear regression equation. So what I've done is I've entered this data into Desmos, creating a table of values. We're going to write each answer as an equation, and we're going to round all values to 3 decimal places. So 3 decimal places after the decimal point. So let's go back to our Desmos. So I've entered the data, as you can see. If you need to pause so that you can enter the data and go through this, I am going to show you a little bit different way of getting this information that's more accurate. So the problem answers that you have on your paper are not the answers that I will be looking for, okay? So important for you to go through this. Once you've got that data entered, we're going to hit that. It looks kind of like a weird percentage point. It's those dots in the upper left-hand corner. We're going to hit those dots, and it gives us a linear regression of 3.79206x minus 82.68722. And it gives us an R value of 0.9763, which is very good. So we're going to come back over here, and I'm going to write those down. It is y equals 3.792x, and then it was a minus 82.687. Now, this says use this equation to predict y equals when x equals 2, to predict y when x equals 2, and then enter the prediction as an equation in the form y equals. Let's go back to Desmos, and I'm going to show you something. We're going to export this as a custom regression. And now I can kind of do things with that regression without messing anything else up. But I'm going to use that regression to find when x equals 2. And quite honestly, I'm not quite, yes, I did need to do this. So now I'm going to, in equation 3, enter x equals 2. And you can see that vertical line. So now with that regression from equation number 2 and equation number 3, you can see the intersection point, and you can get the value of negative 75.103. It's very cool. It's very, 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 very cool. So y is going to equal negative 75.103. So what's not shown here, this right here, should be crossed off. And what you're going to do, let's do this one more time, because we can do this and delete what we did. This is what's wonderful. We don't have to delete everything. We could just delete those 2 steps right there and recreate them. I'm going to hit the 3 dots to the right of linear regression, and I'm going to export as a custom regression. That creates another line that I can now utilize to find intersection points. So I want to find, so I'm going to go to equation 3, and I'm going to create an equation x equals 2, because I want to find the value on that red line when x equals 2. And this intersection point, I just click on it with my mouse, and I get the intersection point, and I get negative 75.103. It's that simple. So now you can replay this section back if you need it. I think what we did was we exported the regression. That gave us an equation in line 2, and then in line 3 we put x equals 2, and then we found the intersection point. between 2 and 3. And that is probably one of the coolest things since sliced bread. Next video, we are going to work with exponential regression. Exponential regression. And you might feel very comfortable with Desmos at this point. What I'm going to make sure that you do is check your answers. And then right here where it says use the regression model to calculate, I don't want you using the equation. I want you to utilize the tools that Desmos has and create that equation 2, equation 3. So export this equation. And then when n equals 15, remember n is just going to be your x value. You'll put x equals 15 and find the intersection point, okay? But that's what I'll do in the next video.